So for your assignment, if you want a remark, then for example, you're not happy with the mark for the first question, then you email Faja. And if you're not happy with the mark for the second question, then you email me. If you are not happy with the third question, then you email Amjet. Cause like, but probably because I did it last Thursday. Yeah, because we did it last Thursday. For the Tuesday one, I don't think they're out yet. So yeah. So first question Faja, second question me, and third question Amjet. Next quiz. What's the next quiz? I have no idea. You check the syllabus. Check syllabus. I think all the schedules are there. Okay. Yeah, it should say on the syllabus. So check that later. And they will send an announcement before the quiz, so you should be notified before the quiz as well. Anyway, tutorial 3. So today your coordinator wants me to talk about first order linear equation. Mainly we'll talk about the technique called integrating factor, which is really useful. I will say it's simple but really useful. And then we'll talk about substitution. Next week we'll talk about exact equation and other stuff, which I don't know what she's gonna cover yet. But this week's material should be simple enough. Let's look at the definition. So first order linear differential equation is a differential equation which can be written in this form. So your A1, A0, they are constant. Oh, actually, never mind. They are functions of x and functions of x. And dy, which is first order. See that this is a highest derivative, so it's first order. It's linear, which they don't tell you what's linear yet. But remember, those has to be functions of x only, not functions of y. Okay, so you cannot have y here. If you have y here, then it's not linear anymore. So equals to g of x. And in standard form, which means we divide both sides by a1x. Okay, remember this cannot be 0 because if it's 0, then it's not the first order differential equation anymore. So this is not 0, that's why you can divide it by a1 of x. Then you will get this, where your px is just a0x divided by a1x, and your qx is just gx over a1x. And they are all functions of x. Here is an example. So we have 13x squared dy over dx minus 2 cosine y, okay, equals to e to the x plus x. So in this case, 13x squared, I'll write it down. So 13x squared, this is your a1x. This whole thing is your a0x. And this whole thing is your g of x. Also, another thing that you should know is that if our g of x equals to 0, then we call it homogeneous. This is just a review for your lecture, okay? And if it's not 0, then we call it non-homogeneous. Alright, so my question is this first order linear equation homogeneous or non-homogeneous? Non-homogeneous, okay? So this is non-homogeneous. And if you want to write it in standard form, then you divide both sides by this. So the standard form will be dy over dx minus 2 cosine x over 13x squared y, which equals 2, e to the x plus x over 13x squared. Okay, so this is your standard form. You should always write your ODE in standard form and then use integrating factor. So what's integrating factor? When you write something in the standard form, the integrating factor, Ix, or whatever your professor call it, is gonna be e to the integral of px. So this thing. So the factor before your y, this thing, remember it has to be in standard form, okay? So whatever the factor or coefficient that y has, you take it e to the integral of that. That's gonna be your integrating factor. So my first question is, what is my integrating factor of this ODE? This ODE, okay? X, no, e to the x cubed, yes, that's correct, okay? So our integrating factor, so Ix equals to e to the integral of 3x squared dx, which will give you e to the x cubed. Okay, so that's your integrating factor. Don't really need to plus c here. Because if you plus c later on, you can get rid of, you can combine that constant in somewhere else, so don't really need to do that. Anyway, here are the steps you need to do when you try to solve a first order linear ODE. So first of all, you write it in standard form, just like we talked about before, and then you calculate the integrating factor, which equals to, recall it again, okay, e to the power of integral px dx, and then you multiply both sides of the differential equation. So you multiply both sides of this by the integrating factor. So that's gonna be Ix dy dx plus Ix px y equals to Ix qx. Okay, so then you need to recollapse the left hand side, which is this side, as a product rule. We'll see that later. Okay, actually I'll write it down. So this is basically what? Oops. This whole thing is basically the derivative of Ixy. Okay, if you take this, you take the derivative of this, you see that, well, you get Ix dy dx, and Ix pxy. Wait. Yeah, it's Ixy prime. Yeah. Yeah, and then you need to integrate both sides of the result and then isolate y, use additional information. Additional information means if you are given initial value to solve the constant. Anyway, let's try this question. So try to solve this ODE. So I told you what the integrating factor is already. So you start from 3. Step 3. Okay, so hopefully everyone got it. Basically, just follow what I wrote before. So you find your integrating factor, we know this already from part A, and then you multiply the integrating factor on both sides of the equation, then you will get this. And then you recollapse this part to the derivative of e to the x cube y, which equals to 1, and then you integrate both sides, okay, dx dx. So on this side you'll get e to the x cubed y, this side you'll get x plus c, where c is a constant, and then you move this to the other side, you'll get this. Okay, any question? If no question, let's say type a number in the chat. Okay, seems like we're good. Are we allowed to leave it in quotient form? What do you mean quotient form? Not sure what do you mean though. Give me an example. Like instead of simplify it to e to the negative x cubed. Instead of, so what do you want the answer? Leave it to be. Oh, I see. Keep this in the denominator. Think that's fine. Yeah, I think that's fine. It's not a big deal. It's better that you simplify it. The reason is that, well, sometimes we mark really fast, and if you don't simplify it, it's really easy to miss your answer. So yeah, for your own good, it's better that you simplify it. Anyway, yeah. Example 2, it's really similar. So try this. Try it yourself. Okay, once you finish it, let's say, what do we want to talk about this time? Type your favorite TV show in the chat. How's that? Tutorial file? Sure. Hold on. Okay, so if you're down, let's type your favorite TV show in the chat. Show, TV show. We can talk about character next time. Okay, now we're talking about TV show. Favorite TV show. Oops. Okay, seems like most of you finished already. let's talk about this. So the first step, we need to check if it's in standard form, and we can tell that it is in standard form. So our integrating factor is e to the power of integral of 4 dx, which will give you e to the 4x. And then you multiply your integrating factor. On both sides, you'll get e to the 4x y prime plus e to the 4x 4y equals to e to the 4x x e to the x. Okay, so on your left hand side, you'll get e to the 4x y, the whole thing prime, equals to x times e to the 5x. And then you integrate both sides, you'll get e to the 4xy equals to 1 over 5 x e to the 5x minus 1 over 25 e to the 5x plus c. Now we just need to move this to the other side. So you'll get y equals to 1 over 5x e to the x, minus 1 over 25 e to the x plus c e to the negative 4x. And now you have the initial value, so you plug this in. Since y0 equals to 1, we know that 1 equals to 0 minus 1 over 25 plus c. So this will give us c equals to 26 over 25. So therefore, your y will be 1 over 5x e to the x minus 1 over 25 e to the x plus 26 over 25 e to the negative 4x. So this is your final solution. Okay, any question? If no question, type a letter in the chat. Okay, nice. All right, so let's do the next one. So the next topic, I hope everyone's good with integrating factor. It's pretty simple. So our next topic is substitution. Okay. So we have homogeneous first order differential equation, which can be written like this. Okay, we have function of y over x. If you make the substitution at v equals to y over x, so y equals to vx, dy over dx will be v plus x dv over dx. Okay, so you take the integral of this. Then this equation is gonna be transformed into a separable equation. Wait, did I even talk about separable equation before? What happens if there is a absolute sign? So if there is absolute sign, you need to discuss cases. So most likely you'll only have the positive part, but sometimes you need to keep both parts, which means you cannot leave the absolute value sign out. So you need to keep it if you have both cases. Okay. Did I talk about separable equation? Let me think. You don't remember? Yeah, separation of variable. I did, right? We talked about it last time. Yeah. Okay. So, yeah. Okay. So if you make the substitution, then we transform this into a separable equation, which means you can use separation of variable to solve it. So, here is an example. Did you guys talk about this substitution method in the lecture? Or no? No, not yet. Okay, so I'm ahead of your lecture. But did you guys talk about integrating factor though? Okay. Okay, cool, cool, cool. So I'll do the first example. We'll do it together, and I'll give you a chance to try the other examples. How's that? Cause you've never seen it before, so I guess you might have problem do it yourself. All right. So what we need to do is first we need to write it as a function of y over x, because remember you want it to be a function of y over x, and then you can substitute y over x with v or u or whatever you want. So I want to do that. What I'm gonna do is I'm gonna do dy over dx equals to I'm gonna divide x on both sides. Okay, so now we have a function of y over x. Now you can make substitutions, so let u equals to y over x. Then my y equals to ux. Okay, now your dy over dx is gonna be d of ux. So because your y is ux, okay, dx, which equals to du dx times x plus u times 1, okay, times 1, which is still u, which equals to, now you substitute this back. Oops, didn't mean to. So you substitute this back into the equation. So that equals to u minus 4 over 1 minus u. Okay, so this, I'm gonna highlight this. This is gonna be your separable equation. Let's continue. So du over dx times x equals to u minus 4 over 1 minus u, which equals to u squared minus 4 over 1 minus u. So now we have this. Now you see that one side we have x, the other side we have u. Okay? So now you can use separation of variables. So now we have integral of 1 over x dx equals to 1 minus u over u squared minus 4 du. So this side will give you ln x equals to, okay, now how do we do this? Anyone remember? Okay, I forgot to check the chat. Wait, where did the plus u come from? Plus u? Oh, it's just, can we use another color? This is just ux prime, because I'm taking the derivative of this. So that's gonna be equals to x times u prime plus u times x prime, which is 1. So that's how we got this. And how we got this is you substitute this back into the ODE. Trig u minus 2 times u plus 2, u minus 2 times u plus 2. And then I'm saying what is the integral of this? Anyone know how to do this? Okay, I'll do it here. So 1 minus u over u squared minus 4 equals to a over u minus 2 plus b over u plus 2. Now you need to find your a and b. Yes. Separate the fraction. Exactly. Alright, so this equals to u minus 2, u plus 2, and then a times u plus 2 plus b times u minus 2. So this will give you a plus b u plus 2a minus 2b over u minus 2, u plus 2. Okay, so now you just need to solve this. Well, this is 1 plus bu plus a constant, so this will be 1, and 1 plus b will be negative 1. So this gives you 1 plus b equals to negative 1, and 2a minus 2b equals to 1. Okay, any question? So this is just 136 material, I think. If you don't remember this part, you should review, okay? And now solve for a and b. A would be, so times 2, 4a equals to minus 1. Okay, a equals to negative 1 over 4, and b is negative 3 over 4. Okay, so you put it back. Negative 1 over 4 times 1 over u minus 2 minus 3 over 4 times 1 over u plus 2, the whole thing du, which will give you negative 1 over 4 log absolute value of u minus 2 minus 3 over 4 log absolute value of u plus 2. Okay? Plus c. Yeah, plus c. Sorry. Any question? No? No question? Okay. So if they ask you for explicitly, then well, you need to write it as x equals to e to the power of blah 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 blah. I mean this, and then plus or minus. Okay. So I'll leave it like this because that's really long. Wait. Wait. What am I saying? No. You're not solving for x. You're solving for y. Yeah, you're solving for y. Yeah. Yeah, my mistake. So you substitute it back and solve for y. In this case, it's really hard to write it as explicit function, so I'll finish writing this. So log absolute value of x equals to negative 1 over 4 log y over x minus 2 minus 3 over 4 log y over x. My y looks really ugly for some reason. Plus 2 plus c. So you need to sub it back, basically, because you want it to be a function of y. Okay, any question? That means no question. Okay, next. Try this one yourself, I guess. Yep. Guys, try this one yourself. What do we want to talk about? Okay, favorite. What about favorite superhero? How's that? Okay, there we go. So after you finish it, tell me who's your favorite superhero? Flash? Superman? Anyone else? Naruto? Does Naruto count as a superhero though? Okay, let's see everything counts. No, we're talking about favorite superhero now. Iron Man? Yeah, it counts. Yeah, we were talking about a favorite show before. Now we changed the topic to favorite superhero. Okay, let's wait for one more of you finish this question and we'll talk about it. Your dad. Oh wow, that's a good answer. Okay, let's do this then. Alright, so first of all, we can write it, the whole ODE, in this form. 1 plus 3y squared over x squared, and then the whole thing over 2y over x. And then the same as before, let u equals to y over x, then y equals to ux, so dy over dx equals to du over dx times x plus u, which equals to 1 plus 3u squared over 2u, and this equals to 1 over 2u plus 3 over 2u. So we have du over dx times x equals to 1 over 2u plus 1 over 2u, which equals to 1 plus u squared over 2u. So now we have this ODE, and we can use separation of variable to solve it. So now we'll integrate both sides. So integral of 2u over 1 plus u squared du equals to the integral of 1 over x du. So this will give us ln 1 plus u squared equals to ln x plus c. So you substitute it back, ln of 1 plus y squared over x squared equals to ln x plus c. So this is our final answer. You did example 5, you said? It's okay. We can come back and do example 4 when we do example 5. Alright, any question? Question? No? No one has any question? Cool. Okay, let's do example 5 then. What do we want this time? Well, if they didn't say that they want explicit answer, then you can leave it like that. But if they said they want explicit answer, then you have to change it to explicit answer. A lot of time it's really hard to write it in explicit answer. Scroll up. Favorite person. Well, favorite person, what if we don't know? So it's not fun. Favorite mathematician. Yeah, we can do that. Favorite mathematician. Yeah, let's do that. Here. Favorite mathematician. Okay, so do example 5. Thank you. Okay, let's say this. Favorite mathematician or favorite scientist? Because not everyone is interested in math, I guess. Okay, seems like most of you finished it. You like his hairstyle? Okay. Oh, I really want to show you my Einstein stamp and sticker, not sticky notes. After I finish this, I'll show you. Okay, I'll turn on my camera and I'll show you after I finish this question. Example 5. Let's quickly finish this. I don't think we'll have time to do this one, but the last one is actually simple. This one is slightly harder than the last one. So this one, first of all, we have dy over dx equals to y over x plus the square root of 1 minus y squared over x squared. Okay? And now let's let u equals to y over x. Then y equals to ux. So dy over dx equals to dux over dx, which equals to du over dx times x plus u, which equals to u plus square root of 1 minus u squared. So du over dx x equals to square root of 1 minus u squared, and integrate both sides, so integral 1 over square root of 1 minus u squared du equals to the integral of 1 over x dx. Alright, so what is on this side? What is this? Anyone remember? Arcsine, exactly. So this is arcsine u equals to log absolute value of x plus c. So arcsine y over x equals to log x plus c. So sine log absolute value of x plus c equals to y over x. So y equals to x times sine log absolute value of x plus c. The reason I do that is because I'm giving an initial value, so I need to calculate my constant. So that means 0 equals to x naught sine log x0 plus c. So that means that c equals to 1 pi minus log x0, where my n is integer. So your y is x times sine log x plus n pi minus log of x0. So this is the final answer. Okay, any question? Nope. Okay, let me show you my step. Do you need the MPI? MPI. MPI. Yeah, I was like, what is MPI? Is it enough to show and see? I'm not sure what your professor wants, but when I took the course, you want everything. But I took it at St. George, so if you see something like this, it's better to confer with your professor, because I don't know what she wants. Or did we get n pi? Here. Because you want the whole thing to be 0. So you want this whole thing to be 0. But sine could be 0 at multiple points. Does that make sense? Because we know sine n pi equals to 0 when n is integer. Okay, let me show you my stem. Do you want to show you? The only reason that I want everything to be in person and everything to be on paper is because I want to use my stickers and my stamps. So I have a whole collection of this. Let me turn on my camera. Okay, there we go. So I have a whole collection here. Can you guys see? Also, I have another one. Let me show you. Oh, so this is my collection of stickers and sticky notes. Let me find my, oh, here, found it. It's like sticky notes, looks like this. I'll show you inside actually. It's like scientist collection as well. So different scientists. So this is, I got it from Tokyo. Here. And then here. And the last is like this. Yeah, I really like this. So when I was in person, whenever my students got perfect on assignment or on quiz, I use my stickers and stamps to encourage them to get more perfect, more 100% in the future. So and also my 102 students. So when I was in person, I was only taking Math 102. So my 102 students used to wanna collect everything. I'll turn off my camera. Yeah, so they used to collect all the scientists. So they need to get 5, because they only have 5 assignments out, and I have 5 scientist stamps. So they wanted to collect everything, and they need to do everything perfectly to get it. Anyway, that's the end of the tutorial. If you have no question, you can leave now. And for the students who just joined, welcome. No problem. See you guys next week. Bring your 1 or 2 receipts to claim your stamps. Sure. When everything's back in person, then I'll do it. What happens if you do the integral in the integrating factor? You get an absolute sign. I'm not sure what you mean. Do you have a specific example? Yeah, the tutorial is done for the first tutorial. Like question 1 on the homework. I haven't looked at your question 1 yet. Well, if you have any question, you can ask in the office hours too.